Hey everybody, Mr. Fortin here, doing problem 8106 that's on your homework tonight. Now we tried to introduce this in class today, the idea of completing a square with these pieces right here to rewrite this, which is in standard form, into its graphing form equivalent. And that is going to make it a lot easier to get the vertex of each parabola. Because remember, the graphing form has h and k in it, right? You can tell what the vertex is right away. You can't tell it from here. All you can tell is that the y-intercept is at 0, 15 here, okay? That's not really that helpful for getting the vertex. Okay, so to reiterate what we did in class today is that we have these pieces, x squared on this one, and then we have 6x's. And I can set up a square with this, okay? I might not have the exact pieces to set up a square exactly with 6x's and 15 ones, but I can get pretty close, okay? So remember, the first thing you gotta do in problems like this is you gotta divide this by 2. Okay, divide this by 2. Okay, so that's gonna equal, meaning I'm gonna divide 6x divided by 2 is gonna equal 3x. That means I'm gonna lay out 3x's in my square that I'm gonna try to complete. Okay, here and here. Okay, because that's going to give me equal width to equal height. Now remember, a square is a perfect expression of a rectangle when this width here is the same as the height, right? So if I have a width of 5, my height is 5, and that rectangle is magically a square, okay? Not going to bother with that right now. We're just going to build a square using the pieces that we have, okay? So what I'm going to know here is that the square that I'm going to try to build is x plus 3 times by x plus 3. Okay, so just by doing that, I've actually found that the h of my parabola, right, the vertex is going to be at -3, okay, because that's the square I'm going to complete, okay? Anyways, if you do this one here, I got 15 ones right now, okay, I got 15 ones right now, and that's far too many, okay, to complete the square. I don't need 15 ones, okay? So what I'm going to do is I'm actually going to write out the whole equation right here, okay? I'm going to set this equal to y, okay, because that's what f of x is. F of x is just a fancy way of saying y. And then I have 15 ones, okay, 15 ones. I have too many ones. How many ones do I need? Well, I need 9 to complete the square, okay? I have too many. I have 15 ones. I have 9, 10, 11, 12, 13, 14, 15, okay? I have 15 ones in addition to my 6x's, okay, and my x squared, okay? That's too many. So what do I need to do? Okay, what I need to do to both sides here, okay, not just the side here where I have x squared plus 6x plus 15, but also to the y side. What I need to do is I need to get rid of these. I need to subtract those 6 ones, okay? And I'm gonna subtract 6 ones from the left side too to keep my equation balanced, okay? So that's step number 1 of this. I'm gonna rewrite this as y minus 6 is equal to, well, what do I have here? I have x squared plus 6x, okay? 3x is here, another 3x is there, plus 9, okay? Or plus 15 minus 6. Because if I took away the 6 from this, I end up with that complete square. That's what I want, right? That's what I want here. So I bring everything down. Y minus 6 equals x squared plus 6x. 15 minus 6, well, that is 9. Okay, and that is my complete square right here. X squared plus 6x plus 9. And because it's a rectangle, I can write it not just as a sum like this, but as a product. Okay, so now I rewrite this. I found the perfect square. I write it in its factored version. Okay, it's write it as a product. And there it is. My k is indeed, plus. I need plus here. X plus 3 is my width and my height here. And my h is indeed going to be -3. Okay, right, so I know my vertex here, or my h is 3, so my coordinate of the vertex, all right, yeah, h is -3. Never mind, what am I talking about? Anyways, so we got this here, and then the last step is I'm just going to add 6 to both sides. Okay, add 6 there. Those cancel out. I get y equals x plus 3 squared plus 6, and there we go. We figured out the first part of the problem, and I can state the vertex of this parabola. Okay, so my vertex is, I need to change the sign here, okay, to make this basically 0. So my vertex is going to be at x is -3. -3 plus 3 would be 0. So that means my y value would be 6. And then that would be the lowest part of my parabola. Let's try this one, okay? This works the same way, okay? The same way I showed you in class. Figure out what the perfect square is going to be. Okay, so I have here x squared, and then I have here -4x's. What am I going to do? I'm going to divide that by 2. So divide -4 by 2, I get -2x, okay? So that means I need to put -2x's on this side, and I need to put negative 2x's on this side of the x squared to set up my square that I'm trying to complete, okay? And in order to do that, I have 9 ones. I have too many ones. Wow, that's a lot of ones, okay? So I'm going to set this equal to y, equal to the y piece. Sorry, there's like not a lot of space right here, okay? And I have my 9 ones. That's too many, okay? I just needed 4, okay? I just needed 4 here to complete this x minus 2 times x minus 2 squared, okay? So I have too many. I have 9 ones, right? It says I have 9 ones right there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what am I going to have to do? Well, if this is my starting expression, in order to complete a perfect square, okay, I need 4 ones. I don't need 9. So what can I do to both sides? Well, I can take away the 5 extra ones I have by subtracting them, as long as I subtract 5 ones from this side. 1, 2, 3, 4, 5, right? So I'd have y minus 5 on this side, y minus 5 on this side, and then I would have x squared minus 4x plus 9. I would take away 5 from this side as well, and this completes my square, because the square, x minus 2 squared, is equivalent to x squared minus 4x, and then 9 minus 5 is 4. Okay, right? I want 4 ones there. I didn't want 9. I had to take away 5 from both sides, okay, to keep my equation balanced. And then this is a perfect square, written as a sum, but I can also write it as a product, okay? And I get y minus 5 equals x minus 2 times x minus 2, which is the same thing as x minus 2 squared, okay? So last step, I'm just going to add 5 to both sides. And I get y is equal to x minus 2 squared plus 5. There's my graphing form, and here's my vertex. Let's do another one right here, okay? Set it on up. Figure out what is the square that you have to complete. X squared is here. What do? Well, this is 8x. I divide by 2. I'm going to lay out 4 x's here. 1, 2, 3, 4. Okay, so that means x plus 4 times by x plus 4 is going to be the square that I'm going to complete. Okay, equal width to equal height means it's a square. Okay, if it's a rectangle that has equal width to equal height, that's what makes up a square, okay? What do I need here? I don't have any ones. Oh, what do I do? What do I do? I know that this whole thing is equal to y, right? Because that's y in disguise. Okay, so I can show that if I want to, is equal to y. I keep forgetting to show that in this video here. What do I need to do to both sides? Well, 4 times 4. That's enough space for 16 ones. 1, 2, 3, 4. 1, 2, 3, 4. I got to add 16 here. Okay, so I got to add 16 to this side. I got to add 16 ones to that side to keep my equation balanced. So I'll do that, okay? Y equals x squared plus 8x. Okay, that's not a complete square here. I need to add 16 to both sides to complete the square. Y plus 16 equals x squared plus 8x plus 16. And as we see right here, x squared plus 8x plus 16 is equivalent to x plus 4 times by x plus 4. Remember, I can write this as a sum, and because I drew it as I got into as a rectangle, I can do this as a sum, right, which is all the individual areas of the pieces added up, or what the base times height is, which is x plus 4 squared. Okay, is that graphing form? No, it's not. I can subtract 16 from both sides to get my k back on the right side, and now this is in my graphing form. Okay, there is my equation, and then here is my answer for vertex. Remember, got to flip the sign of what I see right here, because I need -4 plus 4. That gets me my 0. That means that -4, -16 is going to be the lowest point on my parabola. Can't get any lower than that, right? Because squaring anything other than 0 would give me a positive answer, right? Squaring 0 gives me just 0, so that's the lowest it's going to get. Okay, last one right here. Ooh, this is tricky here. If you didn't do problem 8103 in class, you might have a lot of trouble with this one, even if these ones weren't too bad. Okay, but we start the same way. Okay, divide this by 2. Okay, I get 2.5x. Okay, that's totally fine. 2.5x here, I can totally set up a square. I can cut my tiles in half. That's no problem. Just use your trusty chainsaw. Don't hurt your fingers with that here. Okay, so I got x squared. So that's width x, that's height x. I got 5 x's I need to place. So I'm going to place 2.5 of them. Okay, 2.5x here. Okay, another 2.5x here. And now this looks like more like a generic square, a generic rectangle, okay? So the width of this is going to be 2.5, right? 2.5 times x is 2.5x, and x times 2.5 is 2.5x here. So then what's going to go here? What do I need? Okay, well, I have -2. Okay, I have -2. I might leave that to the outside. I got -2 ones right here. What do I need to get up there? Well, 2.5 times 2.5, that's what needs to go here. Like I need to get a few things, right? I need to get 4 is 2 times 2, okay? But 0.5 times 2.5, you know, there's a lot going on here. You just got to use a calculator, okay? If I use a calculator, okay, 2.5 times 2.5, I get 6.25. Okay, so I need to get this to 6.25. So what do I do? Okay, well, y equals x squared plus 5x minus 2. I need to get that from like the -2 out there. I need to get it to 6.25. So what can I actually do? What can I add to both sides to complete the square here? I could add 6.25 and leave the -2 on the outside. But you know what? Hopefully you get it here. If not, I'll give you the answer. I can add 8.25, okay? And why am I doing that? Well, I need 6.25 here because 2.5 squared is 6.25. And by adding 6.25 plus another 2, which is 8.25, I'll raise this -2 all the way up to 6.25. And I'll be good to go. I'll have a complete square on the right side, and then I'll have all this stuff on the left side that I can clean up kind of later. So I'm going to add 8.25 here. Okay, I'm going to get y plus 8.25 equals x squared plus 5x plus 6.25. And that, my friends, right here is a perfect square. Here's the areas of sum. Here's the areas of product. So I'm going to write it as a product. Y plus 8.25. Remember, everything on the left side I'm just taking down with me here. Let's get rid of the -2 out of the way. Okay? -2 plus 8.25 is the 6.25 there. Okay, right? So that's how we got there. And now I'm going to write it in terms of its product. This as a product down here is just equal to, well, x plus 2.5 times x plus 2.5, or x plus 2.5 squared. Subtract 8.25 from both sides, and I would get x plus 2.5 squared minus 8.25. And my friends, you have just completed the square. To write another graphing form, okay, and my vertex to this one would be -2.5 and then -8. Wait, what happened? 8.25, looks like a 7 there, 8.25. Message me if you have any questions. Yes, you need to dig deep to kind of get this, but it's really just 3 steps. And it unlocks a lot of other stuff that we'll do later in the year in Algebra 1 and then future classes as well. This will be helpful. And I hope it's proved the quadratic formula, which is pretty good. Message me if you have any questions. Thanks for watching. Take care. Bye-bye now.